Let's find the partial fraction decomposition of this rational expression. Step 1 is to factor the denominator. We get x minus 3 times x minus 2. This will tell us the number of partial fractions that we need. We'll have two fractions since we have two factors in the denominator. A over x minus 3 and b over x minus 2. Our goal is to now figure out what a and b are. The next step is to multiply both sides of the equation by the LCD. In this case, the LCD is what we started with in the denominator, the factored version, x minus 3 times x minus 2. So we'll do that on both sides. On the left side, we have this LCD times the fraction. Notice that the denominator and the LCD are the same, so those are going to reduce or cancel each other, leaving us with just x on the left side. And then we need to distribute this LCD with the first fraction. When we do that, notice x minus 3 is going to go away, so we're left with a times x minus 2. And then we have to distribute the LCD with the second fraction. In this case, x minus 2 is going to go away, leaving us with b times x minus 3. At this point, we can go through and distribute the a and b to clean up the parentheses and remove them. We get ax minus 2a plus bx minus 3b. Next, on the right side, let's group the x's together and the constants together. So we have ax plus bx minus 2a minus 3b. Next, let's factor out an x on those first two terms. This next part's probably the craziest part. We're going to create a system of equations by looking at the coefficients on the x terms and then the constants. Notice that the coefficient on x here is a plus b. So the coefficient on x is a plus b. We want to set that equal to the coefficient of x that's on the left side as well. We don't see anything there. It's understood to be a 1. And then we'll do the same thing with the constants. The constants on the right side are minus 2a minus 3b. We're going to set that equal to the constant that is on the left side. We don't see anything, so there's a 0 there. So we can make that 0. Notice now what we have. We have a system of linear equations. We can put that in a matrix. So we have 1, 1, 1, negative 2, negative 3, 0. And we want to reduce that. So in the calculator, to get to matrix, notice it's here, it's in blue. We need to hit second matrix. Then we'll go right to edit. Hit enter. Now we need to tell it the size. This is a 2. Enter 3. Enter 2 by 3 matrix. Then we'll type in the entries. 1, enter, 1, enter, and so on. Negative 2, negative 3, 0. Anytime you enter in numbers into a matrix, always double check, make sure there are no typos. Next, we'll exit the matrix, so hit second quit. Now we need to reduce it. So go to second matrix. Then we're going to go right to math. And then we'll scroll until we find RREF. Hit enter. We should see the RREF on our screen now. Now we need to tell the calculator what to reduce. We want it to reduce matrix A. So go back to the matrix. Notice it'll automatically be highlighted on A. We just have to hit enter. That will put matrix A into the ref function. We can close the parenthesis if we want. Don't really have to, and then hit enter, and it will give us a reduced matrix. So when we did RREF, we were left with 1, 0, 3, 0, 1, negative 2. And remember that those are your values for A and B. So now we can rewrite the original rational expression. The original was x over x squared minus 5x plus 6. And when we simplified that, we got two partial fractions. A, which we found to be 3, over x minus 3, plus b, which we found to be negative 2, over x minus 2. And we now have the partial fraction decomposition of that original rational expression.